Good morning to Madam Aswani and our fellow friends. Today we are going to present about ordinary differential equations. I myself is PALANIVELU and my two group mates who are VAISNAVI PRABAGARAN and ALIYA MAISARA BINTI. So the core courses for this presentation is FB 20154 Mathematics 2, SESI 2024 2025, and our lecturer is Madam Aswani Binti Bacho. So this is our group members, me Parameswary, my other group mates Vaishnavi and Nur Arya Maisara. So this is the content of this presentation. First, introduction to ODE. Next is introduction to first ordinary differential equation. Third is application of first ODE in the cooling of a heated metal rod. Fourth is problem statement. Five is step-by-step solution. Six is real-life impact of modeling of cooling object. Seven is discussion. Eight is conclusion, and the last is reference. So, first, introduction to ordinary differential equation. Ordinary differential equation are equations that involve a dependent variable, independent variable, and one or more derivative of the dependent variables with respect to the independent variable. They are called ordinary because they contain derivative with respect to a single independent variable, unlike partial differential equations, which involve multiple variables. ODEs are widely used in science and engineering to model real world systems such as mechanical vibrations, electrical circuits, fluid flow, and population dynamics. Okay, there are a few things to know about ordinary differential equation. First is type of differential equation which depend on the highest order of derivative. Second is order of differential equation which is the highest derivative in the equation. Third is degree which is the power of highest derivative equation. So this is a example of the equation. So to determine the type of this equation, first we have to find the highest order of this equation. So in this equation, d3y over dx3. So the 3 is the highest order comparing to d2y over dx2. So to determine the degree of the ordinate this equation, we have to see the power of highest derivative. So it is 2. So to determine the type of the of this equation, we have to see the highest or highest order. So it is 3. So the type of the equation is third ordinary differential equation. So, next, what is first ordinary differential equation? So, the first ordinary differential equation only have one variable. So, the equation will be dy over dx, which will integrate into y. So, the application of first ODE in the cooling of a heated metal rod. This is our problem statement. So, this application is used in heat transfer field. In manufacturing process, a metal rod is heated to a high temperature. Engineers need to predict how fast the rod will cool to determine the optimal time to handle or process it further. So the first ODE used in this situation is dt over dt equals to negative k bracket T minus T ambient. So where T is the temperature of the rod at time, T ambient is the ambient temperature, which is the temperature in the environment, and K is the positive constant depending on the material and the environment. Next, I will pass to Vaishnavi.
Okay, next we will go to the question. The question for our presentation is the rate of change of temperature T of a hot metal rod is described by the following first ordinary differential equation, which is dt over dt is equals to negative 0.1 in bracket T minus 30, where T is the temperature of the rod in degrees Celsius at time small t in minutes. And the second is the surrounding temperature is 30 degrees Celsius. So now we will go to the question. If the initial temperature of the rod is 90 degrees Celsius, first question is solve the differential equation to find the expression for T. And the second question is calculate the temperature of the rod after 5 minutes. And the third is determine how long it will take for the rod to cool to 40 degrees Celsius. So now we will go for the first question, which is solve the differential equation to find the expression for T. So as this first step, we have to separate the variable. So as this is the original equation, so as we have to separate this equation, we have to bring this dt to right hand side and bring this t minus 30 into left hand side. So this is the equation we will get if we separate the variable, and we have to integrate both sides as the next step. So if we integrate, we will get ln t minus 30 and equals to negative 0.1 t plus c. So next step is we have to exponentiate the both side, because as you can see here, there is a ln at here. So left hand side ln, if we bring to right hand side, it will become exponent. So as we can see here, this ln has been taken to right hand side as exponent, and negative 0.1 t plus c has become the power of the if of the exponent. So t minus 30 is equals to c e negative 0.1 t. Why the c is here? Because we have let c is equals to ec. This ec we have let as a c, so it has become it has bring to the in front of the equation. And next, t minus 30 is equals to ce negative 0.1 t. And the final equation we can see here is t is equals to 30 plus ce power of negative 0.1 t. Why there is c here? Negative 30 has bring to right hand side, and it has become positive 30. So next step, we have to apply the initial condition, which is T0 is equals to 90. So T0 is equals to 30 plus CE. Why here is 0? Because negative 0.1 times 0 is 0. So that's the reason why E is equals to 0 at E power of 0. So 30 plus C is equals to 90. E power of 0 is equals to 1. So C times 1 is C lah. So 30 plus C is equals to 90. So 30 bring to right hand side. 90 minus 30, you will get 60. So C is equals to 30. C is equals to 60. So the solution is t is equals to 30 plus 60 exponent negative 0.1 t. Okay, next we will go to the second question, which is calculate the temperature of the rod after 5 minutes. So t will be 5 minutes, and we have to find the temperature. So 30 plus 60 exponent negative 0.1 times 5, since we have to find after 5 minutes. So 30 plus 60e negative 0.1 times 5, we will get negative 0.5. So 30 plus 60 exponent negative 0.5, we will get 0.6065. So 60 times 0.6065, we will get 36.39. So 30 plus 36.39, we will get 66.39 degrees Celsius as the final answer. So next we will go for the third question, which is determine how long it will take for the rod to cool to 40 degrees Celsius. So we have to find here the time. So as we can see here, 40 is the temperature. So 40 is equals to 30 plus 60 exponent negative 0.1 t, since we have to find the t at here. So this 30 we will bring to the left hand side. So 40 minus 30, we will get 10. equals to 60e negative 0.1 t. Just write it back. And then next we will bring the 60 to the left hand side. So 10 over 60 we will get 1 over 6 as we can see here, and then exponent negative 0.1 t, it will be just written down. So this exponent we will bring to the right hand side has ln. So t is equals to ln 1 over 6 over, and here we can see 0.1 is in times. So as we can see, here it is in times. So when we bring it to the right hand side, it will become divide. And we can see here there is negative, so it will be there negative lah. So negative ln 1 over 6, negative ln 1 over 6 over 0.1, we will get ln 6 over 0.1. So ln 6 we will get 1.7918 over 0.1, and the final answer will be 17.92 minutes. Okay, next I will pass to Maisara.
Okay, the next part, I will be explaining about the real life impact of modeling of cooling object. Okay, first of all, the impact is from a forensic science. So, the impact is it helps determine time of death by measuring body temperature and estimating how long a body has been cooling. And then the use is investigators apply the cooling law to estimate how many hours have passed since that. And secondly is food safety. The impact is it will ensure proper cooling of food to avoid bacterial growth. So the use is it will predict how fast hot food cools to save temperature to prevent foodborne illness. And then the third one is electronics and engineering. So the impact is it will guide a thermal management in designing circuits or cooling system for computers and engines. And the use is it will estimate how quickly a heated component will cool to prevent overheating or thermal damage. And then we'll move to the second slide, which is the fourth one, which is environmental sign. So the impact is uh, we will understand temperature decay in water or soil after heating events such as forest fires or pollution spill. So the use is I will predict cooling of lakes or river after industrial discharge. And then the last one for the real life impact is uh, which is a home or a building design. So the impact is it will inform energy efficient insulation and air conditioning design. So the use is engineers model um, engineers model how rooms lose heat to optimize heating, ventilation, and air conditioning in a bracket HVAC system. Okay, that is for real life impact of modeling, and then we'll move back to discussion. Okay, so as you can see, this is our discussion. Okay, what we can summarize in our discussion is okay. This slide explain how Newton law of cooling was applied to a real world problem: the cooling of hot metal rod in a room with an ambient temperature of 30 Celsius. So the key point in our discussion is the temperature change was modeled using a first order separable differential equation. And then the general solution that we found was T in the bracket equals to 30 plus 60 exponent power in the bracket negative 0.1 T. Okay, which give the temperature of the rod at any time T. Okay, by using the initial condition T in a bracket 0 equals to 90 Celsius, the constant in the equation was determined. Okay, so the calculation was shown. Okay, after 5 minutes, the temperature is around 66.39 Celsius. And then time for the rod to cool to 40 Celsius is about 17.9 17.9 minutes. Okay. That is for our discussion, and we've moved back to the second slide, which is conclusion. Okay, this is our conclusion. So basically this slide summarize the finding, the border significance of the study. So the key point for our conclusion is the